Welcome to the TCAS lesson in the PMDG 737 Next Generation Groundwork from Angle of Attack. This lesson will cover the following topics. We'll start with an overview of the background and objectives of TCAS. We'll explain briefly how transponders and TCAS work, and we'll discuss TCAS advisories and displays and TCAS mode control. So what is TCAS? TCAS stands for Traffic Alert and Collision Avoidance System. It is a system designed to identify and reduce the risk of mid-air collisions between aircraft. It provides traffic displays, alerts, and resolution advisories to the crew to improve their situational awareness and assist them in resolving a conflict. Aviation has had a long and troubling history of mid-air collisions, dating back to its earliest days. During the 1950s, air traffic was continuing to grow at an ever-increasing rate, and so was the risk of mid-air collisions. As concerns grew over the rising risk, research was conducted into proximity warning devices that might reduce it. The 1956 collision between a Lockheed Super Constellation and a DC-7 over the Grand Canyon outlined the need for both a reformed ATC system and accelerated development of a proximity warning device. A continuing trend of mid-air collisions continued throughout the 60s and 70s, however, with each accident continuing to catalyze development of collision avoidance systems. The FAA finally made TCAS mandatory in US airspace in 1993, following the 1986 collision between a DC-9 and a Piper Archer over Cerritos, California, which resulted in the loss of 82 lives. There are two principal versions of TCAS currently in commercial service, TCAS 1 and TCAS 2. TCAS 1 is designed primarily for general aviation and for small regional airliners, and it provides a traffic display and traffic advisories only. TCAS 2 is used on the majority of commercial airliners and adds several improvements over TCAS 1, most notably the ability to issue resolution advisories. The FAA mandates TCAS 2 on aircraft with more than 30 seats, or those that weigh more than 15,000 kilograms. The rules are more stringent in Europe under EASA. Currently operational on most aircraft is TCAS 2 version 7. Version 7.1 has been projected for mandate by EASA on new-build aircraft in March 2012 and for retrofit by December 2015. Version 7.1 introduces improvements designed to overcome weaknesses that failed to avert the 2002 Überlingen disaster in Germany. Studies conducted for Eurocontrol, the European Organization for the Safety of Air Navigation, indicate that the current probability of a mid-air collision in European airspace is 2.7 times 10 to the minus 8. This equates to one mid-air collision every 3 years. Implementation of TCAS 2 version 7.1 should reduce this by a factor of 4. TCAS 2 version 7 is our main focus here, however, as that is what is installed on our 737. TCAS continuously interrogates operating transponders in other aircraft to predict their positions and flight paths. It then provides traffic displays and advisories to the flight crew. A transponder is a device that automatically transmits a coded signal when interrogated by ATC ground radar or TCAS. The term transponder is short for transmitter responder, which describes its basic functionality well. Key to the content of the signal sent out by a transponder is the altitude of the aircraft. There are three main types of transponders in operation in civil aviation: Mode A, Mode C, and Mode S transponders. When Mode A transponders are interrogated by ATC ground radar or TCAS, they transmit a 4-digit squawk code. This squawk code is used by ATC to identify the aircraft. Mode C transponders also transmit a 4-digit squawk code when interrogated, but also include altitude information. This altitude information is available to both ATC and to TCAS in other aircraft. Mode S transponders include all of the functionality of Mode A and C transponders, but add many more features to the mix. Mode S adds improved accuracy, improved interrogation capabilities, and most significantly, a communication data link. This data link is used by TCAS-2 to coordinate resolution advisories between two aircraft. A Mode S transponder is therefore a requirement for a TCAS-2 installation. We will talk further about the other transponder modes and their effects on TCAS later in the lesson. So how does TCAS work? TCAS and the transponder are inherently linked. TCAS interrogates operating transponders in other aircraft, analyzes the transponder replies, and predicts the position and flight paths of those aircraft. Directional radio antennas on the top and bottom of the fuselage determine the range, bearing, and speed of the other aircraft. TCAS then computes the position and projected flight path of those aircraft. Altitude information may also be received from the other aircraft's transponder if available, and vertical speed may then be calculated. TCAS issues traffic advisories and resolution advisories as appropriate to avoid mid-air collisions. A traffic advisory, or TA, is an oral and visual alert to draw the flight crew's attention to closing traffic. Traffic advisories assist the pilot in the visual search for the intruder aircraft and prepare the pilot for a potential resolution advisory. A resolution advisory, or RA, is a recommended maneuver that will either increase or maintain the existing vertical separation from the intruder aircraft. TCAS issues an RA both orally and in the form of visual cues on the primary flight display. We will elaborate further on both traffic and resolution advisories later in the lesson. The advisory capability of TCAS is dependent on the transponder mode of the conflicting aircraft. If the transponder of a conflicting aircraft is switched off or standby, that traffic will be invisible to TCAS. TCAS only sends out Mode C and Mode S interrogations. A Mode A only capable transponder will not reply to TCAS interrogations and will therefore be invisible to TCAS. A Mode C transponder with altitude reporting selected off will reply to TCAS interrogations, however. TCAS traffic symbols and traffic advisories will be available, however resolution advisories will not be available due to the lack of altitude data. Additionally, traffic symbols on the navigation display will not display altitude. A Mode C transponder with altitude reporting selected on will reply to TCAS interrogations and will supply altitude information. Traffic symbols on the navigation display will display altitude data, and both traffic and resolution advisories will be available. Coordinated resolution advisories will not be available, however, as this feature requires the Mode S data link and TCAS-2 installation in the other aircraft. If the other aircraft has a Mode S transponder and TCAS-2 installed, then the two TCAS systems may establish communications and coordinate resolution advisories. This ensures that the two resolution advisories given will be compatible and not worsen the situation. To provide advisories, TCAS constructs a three-dimensional airspace around the aircraft where a high likelihood of traffic conflict exists. The dimensions of this airspace vary depending on the closure rate with the conflicting traffic. Traffic advisories and resolution advisories are generated based on a closest point of approach, or CPA. The closest point of approach is the point at which the separation between the two aircraft will reach a minimum value. TCAS calculates the time to reach the closest point of approach by dividing the distance by the closure rate. This is effectively a distance speed time calculation. Traffic and resolution advisories are then issued based on this time. A traffic advisory is generated when the other aircraft is approximately 40 seconds from the closest point of approach, and a resolution advisory is generated when the other aircraft is approximately 25 seconds from the closest point of approach. TCAS issues oral advisories and visual displays to the flight crew. Visual indications are present both on the primary flight display and the navigation display. The navigation display displays TCAS traffic symbols, TCAS annunciations, and other TCAS information. TCAS annunciations are displayed in the lower left of the navigation display, and these indicate the status of the system. An amber TCAS off annunciation is self-explanatory. It indicates that TCAS is simply switched off. A cyan TA only annunciation indicates that TCAS is set to traffic advisory only mode, so resolution advisories are disabled and will not be generated. TFC, or traffic, indicates that the traffic switch on the EFIS control panel has been selected on, and the navigation display TCAS display is active. TCAS test indicates that the TCAS is operating in test mode, and the corresponding indications are active on the display.
TCAS test pass.
We will be revisiting these 4 annunciations later in the lesson. An amber TCAS fail annunciation may also appear, and this indicates that the TCAS system has failed.
TCAS test fail.
TCAS traffic symbols may be displayed on the navigation display using a traffic switch on the EFIS control panel. When traffic is selected on, the cyan traffic annunciation appears. Traffic may be displayed on the navigation display by a variety of symbols. Symbols may be white, yellow, or red depending on the severity of the situation. There are 4 main classes of symbol that TCAS will generate on the navigation display: an open white diamond, a filled white diamond, a filled amber circle, and a solid red square. The symbol may have an associated altitude tag attached to it, which displays the relative altitude to your aircraft in hundreds of feet, whether the aircraft is above or below you, and whether the aircraft is climbing, flying level, or descending. The altitude trend arrow only displays when the traffic is climbing or descending at rates greater than 500 feet per minute. This altitude information is dependent on the other aircraft's transponder reporting altitude. If altitude information is not being transmitted, the symbol will not have an altitude tag, and resolution advisories will not be generated. An open white diamond indicates non-threat traffic that is greater than 6 nautical miles away, or is greater than plus or minus 1,200 feet vertically. This is simply referred to as other traffic. A filled white diamond indicates traffic that is less than 6 nautical miles away, and within 1,200 feet vertically. This traffic is still not considered a threat, but is referred to as proximate traffic. A symbol change to a filled amber circle indicates that the intruding aircraft is now considered to be potentially hazardous. This occurs when the intruding aircraft is approximately 40 seconds from the closest point of approach. This is called a traffic advisory and is indicated orally by a
traffic
message. The oral alert will sound only once and will then be reset for another future traffic advisory. A pilot should never try to self-separate from a traffic advisory. When the traffic is approximately 25 seconds from the closest point of approach, the symbol will change to a solid red square and a resolution advisory will be issued. A typical TCAS-2 resolution advisory requires a response within 5 seconds and G-forces of plus or minus 0.25 G. Because of this G-force requirement and the immediacy of the response required, the autopilot must be disconnected prior to responding to the resolution advisory. As we discussed earlier, TCAS-2 is capable of coordinating resolution advisories via the MODES data link. This is dependent on the intruder aircraft also having an operational TCAS-2 installation, but is effective in ensuring that the resolution advisories are compatible with one another and will not worsen the situation. There are many resolution advisory orals, and visual commands on the PFD vary depending on the type of advisory triggered. Resolution advisories may be broken down into two types: preventative advisories and corrective advisories. Corrective advisories require that the flight crew take positive action to maneuver away from the other aircraft. Preventative advisories require that the flight path of the aircraft be maintained. There are three oral preventative advisories.
Monitor vertical speed.
This resolution advisory requires that the pilot avoid the pitch areas highlighted on the attitude indicator. A TCAS vertical speed tape on the vertical speed indicator, or VSI, is a custom option on the 737 Next Generation. The red areas should be avoided. A monitor vertical speed resolution advisory rarely requires a change in vertical speed. You might expect this resolution advisory if targets are approaching from both above and below the aircraft, and vertical speed must be monitored closely to maintain separation.
Maintain vertical speed. Maintain.
This resolution advisory requires that the pilot maintain a rate of climb or descent in accordance with the indications on the PFD attitude indicator and VSI. The pilot should always follow the guidance given on the PFD in this case, rather than trying to chase the exact vertical speed that was current when the RA was issued. Following the guidance ensures that the resultant vertical speed is sufficient to satisfy the RA.
Maintain vertical speed. Crossing. Maintain.
This resolution advisory should be flown in the same way as maintain vertical speed, maintain, and the inclusion of crossing in the oral message is merely for the pilot's information. This indicates that his aircraft will pass through the level of the intruder aircraft while the RA is followed. The rest of the resolution advisory orals are corrective advisories and require positive action by the pilot to maneuver the aircraft.
Climb. Climb.
This resolution advisory requires that the pilot climb to avoid the pitch regions displayed on the PFD. In this case, the clear, safe region will be towards the top of the attitude indicator, prompting the pilot to pitch up. Don't forget that TCAS is expecting you to respond within 5 seconds and achieve a load factor of at least 1.25 G in the pitch up to climb. The autopilot must be disconnected for this type of resolution advisory.
Descend. Descend.
This resolution advisory requires that the pilot descend away from the red pitch regions on the PFD. Descend resolution advisories are inhibited below approximately 1,100 feet radio altitude due to the lack of safe terrain clearance. Crossing climb and crossing descend resolution advisories are also issued where the intruder aircraft will pass through your level during the maneuver. TCAS may sometimes reverse its initial resolution advisory command. Where the initial command was to descend, a reversal would result in the oral callout.
Climb. Climb now. Climb. Climb now.
Where the initial command was to climb, a reversal would result in the oral callout.
Descend. Descend now. Descend. Descend now.
The aircraft must be pitched without delay to the new revised altitude, and the PFD guidance should be followed to achieve this. The reversal should be made within 2.5 seconds, with additional load factor at plus or minus 0.35 G. Further resolution advisory orals may be issued where the current rate of climb or descent is insufficient to resolve the conflict. Guidance will be given for both of these commands on the PFD. Increased descent resolution advisories are inhibited below approximately 1,500 feet radio altitude, so that pilots are not encouraged to descend too quickly close to terrain. TCAS may also issue oral messages to reduce vertical speed.
Adjust vertical speed. Adjust.
This resolution advisory requires that the pilot reduce the aircraft's vertical speed. This may be triggered both as an initial resolution advisory and as a weakening resolution advisory. As an initial resolution advisory, adjust vertical speed is commanded to maintain separation between the two aircraft and avoid a conflict. It may also be issued following a climb or descent resolution advisory where the current rate of climb or descent is greater than needed, and this minimizes ATC disruption. When any traffic or resolution advisory occurs, a traffic message will appear on the navigation display. This will be amber for a traffic advisory and red for a resolution advisory. If the navigation display range is too close, and traffic or resolution advisory traffic is not displayed as a result, an off-scale message will appear. If the bearing of traffic cannot be determined, it cannot be displayed as a traffic symbol on the navigation display. If that traffic qualifies for a traffic or resolution advisory, a no bearing message will appear. This provides range, relative altitude, and a vertical motion arrow. All resolution advisories are inhibited below approximately 1,000 feet radio altitude, and oral traffic advisories are inhibited below approximately 500 feet radio altitude. After a resolution advisory traffic conflict has ended and traffic separation is increasing again, a clear of conflict oral message will sound, and all corresponding indications will disappear.
Clear of conflict.
TCAS mode control is conducted from the transponder panel, located on the aft electronics panel. We will run through every control on this panel for familiarization. The 737 Next Generation has two transponders which are individually selectable using the transponder selector at the top left of the panel. Altitude data for Mode C and Mode S reporting can be taken from either of the two air data computers. The altitude source selector allows the crew to manually select the data source for altitude reporting. When flying into RVSM airspace, the source selected should correspond to the primary altimeter referenced by the autopilot in use. For Autopilot A, this is Air Data Computer number 1, and for Autopilot B, Air Data Computer number 2. The two code selectors allow pilots to enter the transponder code assigned to them into the code indicator window. An identification signal may be transmitted manually by pushing the ident button. This is done in response to ATC requests to ident. The transponder fail light indicates a transponder malfunction when lit. The control on this panel most relevant to this lesson and TCAS in general is the transponder mode selector. This is a 5-position selector with a push button mounted on it. The push button is a test switch that starts a test of the TCAS system. Symbols appear on the navigation display, along with the TCAS test enunciation. An oral enunciation signals the outcome of the test.
TCAS test. Pass.
Pass also indicates in the transponder window, and the transponder fail light illuminates to indicate that the selected transponder is operational. The transponder mode selector may be rotated to select one of the 5 transponder operating modes. The standby position places the transponder and the TCAS system in standby. In this mode, the transponder will not transmit. When set to the altitude reporting off position, the transponder operates but without altitude reporting. The transponder position enables altitude reporting, but traffic and resolution advisories are still disabled. The TA-only position enables TCAS traffic advisories, and the TA-RA position enables resolution advisories additionally. Depending on airline standard operating procedure, the TA-only mode may sometimes be selected following an engine shutdown in flight. TCAS does not take into account aircraft performance capability when issuing resolution advisories. A 737 with an engine out may have inadequate climb performance to fully comply with climb resolution advisories. Selecting TA only avoids the issuance of resolution advisories that the aircraft would be unable to comply with. We'll finish up as always with the lesson summary. TCAS is the last line of defense against a mid-air collision. It is completely independent of ground-based air traffic control. This is both a strength and a weakness. TCAS does not facilitate automatic reporting of resolution advisories to ATC. This places additional burden on the pilots in an already high workload situation and does not immediately keep the controller in the loop. It does, however, mean that resolution advisories are issued regardless of ATC communication, making controller mistakes irrelevant so long as the resolution advisory is followed. Air traffic controllers, like pilots, are only human and do make mistakes, so TCAS acts as a further safety net. Resolution advisories must be followed, even if you think you have the traffic in sight. The traffic you see may not be the traffic that the RA is maneuvering you to avoid. Familiarity with the various TCAS advisories is crucial. TCAS expects a response within 5 seconds of initial resolution advisory and within 2.5 seconds of a resolution advisory reversal. This is not enough time to mull over what you should be doing. In this lesson, we covered an overview of the background and objectives of TCAS, an explanation of how transponders and TCAS work, TCAS advisories and displays, and TCAS mode control.